Good morning, everyone, or afternoon, or evening, depending where you're watching from. Let me just check that my audio and everything is working. And as always, if somebody's already watching, let me know in the chat that you can hear and see me. That's always good for me to double check. And we'll get started in just a couple minutes here. Again, I'm just kind of making sure everything is live. And feel free to say hello in the chat. And you can let me know how you're doing doing today. And it's always fun to hear kind of if anyone's implemented ML monitoring before. Maybe you've put a model in production. If you have any stories you'd want to share about that, please let us know in the chat as well. And it's fun to kind of introduce yourself. Again, I'll bring this up in a few minutes as we get going. But if you want to introduce yourself in the chat for me, but also for everyone else watching, I think it's fun to kind of see who else is at these events. And again, we'll get started in just a couple minutes. I'm going to wait for people to join. I see a few people here already. Sometimes there's a little bit of delay for me starting the stream as well. So we'll just give it a couple minutes before we get going on the content. But again, if you're just joining, say hello in the chat, maybe where you're watching from, why you're interested in ML monitoring. Are you using Databricks right now? Do you have models in production? It's always fun to kind of hear a little bit about what people are working on. And while people are joining, I'll just also mention we're going to do some slides, but then most of this is going to be kind of a hands-on workshop. If you want to follow along, or you can just watch what we're doing as well, that's also welcomed. I'm going to share some links in the chat for everyone if you want to follow along. There's just a little bit of setup you'll do. It's pretty easy, so it should just take a few minutes. And I'll bring this up as we go along as well. There'll be another opportunity for this, but I definitely recommend getting a little bit of setup right now. Someone said, hello from Seattle area. I'm also from Seattle, and thank you for talking in the chat. So I'm going to share a couple links if you want to set up and follow along. The first thing is you'll want to sign up for a WhyLabs account. That's what we're going to be using today to kind of do ML monitoring. It's free. There's no card required. You just want to sign up and then verify your email, and we should be good to go. And then the next one, again, if you want to follow along, on the Databricks side, is you'll want to have a Databricks account. There is a way to make a Databricks account with a community edition. So if you don't already have one, you don't have a cluster, you can set up a community edition account. Let me go grab that link real quick, actually. If you want to see the docs, it's just when you sign up on the second screen, when it asks you to select which cloud provider you want, there's a little link kind of down below saying you want to do a community edition. And that way you don't have to spin up your own AWS or Azure instance if you want to run this right now. Again, if you already have a Databricks account, you can kind of skip that step. And then, and again, I'll share these a little bit later as well, but you might want to open this up already. Here is a Databricks notebook. So this is going to be the notebook that we're going to run through when we get to that part. Again, I see some people just joined. We're going to do some slides, and then we're going to do kind of some hands-on part running code in a Databricks notebook. And then if you want to check out WhyLogs, which is the open source library we're going to be using to collect telemetry for logging. And then one more link. You don't have to worry about this one if you don't want to. This is just optional if you, for whatever reason, don't want to create that Databricks account right now. You can run pretty much a very similar example as what we're going to be doing today in a Google Colab, which is a way of running a Jupyter notebook in kind of Google Drive. So just if you're doing that, save a copy in your own drive, and you'll be able to run all the code there, and hopefully everything should work pretty smoothly. And we'll wait one more minute, and then we're going to get going. And again, I saw some people join, so definitely say hello in the chat. Maybe tell us a bit about what you're working on, why you're interested in ML monitoring. And if you're already using Databricks, I think that'd be fun to hear as well. And let me just copy 2 of these links over to, I'm streaming on YouTube and LinkedIn, and I think the comments there don't go to LinkedIn. So if you want to sign up for the account, I'll paste this in. And then the Databricks notebook. I'll also paste this over to LinkedIn. And I'll paste the Colab one as well. And again, this is going to be for the hands-on part. All right, everyone. Are we ready to get going? I think so. And I saw someone typed in. They're from Seattle. I'm assuming you can hear me. I'm going to go ahead and get going, but let me know if you can't hear me or can't see my screen in the chat, or if you just want to say hello. So this is WhyLabs and Databricks, simplifying ML monitoring in complex environments. And again, there's the setup links. If you're watching on YouTube, all of these links are also in the description. So if it's easier for you to just click on them there, you can find them if you expand the description below the video. So what this workshop is, hopefully it's a very friendly introduction to ML monitoring in Databricks with WhyLabs. So it's kind of designed with no experience, presumed around ML monitoring, potentially even a Databricks. So we're going to walk through, run all the code, and I'll kind of cover what's happening. But knowing some Python and machine learning will definitely be helpful. That being said, if you are super new, you can run the code cells, and I'll explain what's going on. So hopefully you will learn something from it, even if you don't have a lot of experience in Python or machine learning. So again, we're going to cover some of the high-level concepts, and then we're going to do some hands-on part of like running code in a Databricks notebook and look at what ML monitoring could look like in your environment. A quick introduction. My name is Sage Elliott. I'm a machine learning and MLOps evangelist at WhyLabs. We create tools for observing and monitoring data and ML models, mainly in production. And we're going to talk more about this later. For over the last decade, I've worked as a software or machine learning engineer or hardware engineer, mostly with startups and some agencies around Seattle and Central Florida. And I love making things with technology. And people say I look a lot different now. This is actually just a few months ago, but I think I grew all my hair out. A little bit about you. So again, I saw more people join. If you want to throw in the chat, where are you watching from at the bare minimum? That's fun to hear. But also, why are you interested in ML monitoring? I think that'd be cool to hear. And if you have any models in production, you want to tell a story about maybe, you don't have to go into details, but have you ever had any interesting things happen with models in production? It's kind of where ML monitoring comes in. And if you want to stay connected, you can join the link to the Slack or join the Slack group. Again, the link is in the description as well, but I just posted it in the chat. So if you want to stay connected with me or kind of other industry experts, that's going to be a good place to do it. And there's a channel you can introduce yourself in there. So again, I already went through the setup. I'm not going to copy all these links in to the chat again. Again, they should be in the description on YouTube. I also put them in the chat. We're going to run code in a Databricks notebook, but there is an optional Colab one if you want to run it there instead. And then other than that, you'll just want to sign up for a WhyLabs free account. Again, no card or anything required. Same with Databricks. They have a community version that you can sign up for free. No card or anything required. Again, both of those, you just verify your email and you'll be good to go. And again, we're going to be using Databricks kind of as our environment to run all this in. And we're going to use scikit-learn as our ML package to train a model. And then we're going to use MLflow for model and data registry in Databricks. And then we're going to use WhyLogs to collect some telemetry for logging and ML monitoring. And then we're going to use WhyLabs to kind of look at that data and set up alerts. So if anything does change, we can take some action on that. So just a quick kind of recap. And again, you could let me know in the chat if you've used Databricks or you're currently using Databricks. Databricks is a really cool environment that kind of unifies most of the areas in machine learning or data analytics in a unified platform. So again, we'll be taking a look more at this in a little bit of what your whole ML workflow might look like in here. But it provides a really cool, collaborative, pretty intuitive space to work in. And it's built on top of Apache Spark, so it can scale up very nicely to your needs, whether that's like hyperparameter tuning or you're training or serving a model. There's a lot of really cool stuff you can do with it. And it integrates with most of the major cloud solutions that you're probably using. So if you sign up for Databricks, you usually choose like, do you want to use AWS, Azure, Google Cloud, etc., which is really cool. So the ML lifecycle in Databricks looks kind of something like this. Again, it might vary on your project, and you might be using components outside of Databricks. But you can basically do most of the things in the platform here. You're getting your data. You might be doing feature engineering in a pipeline. You can store that data, and then you can do your training pipelines, your evaluation pipeline, and then even do your model serving, and then store the results from the inference once your model's in production. And today we're going to use MLflow a little bit in our notebook today and show it how you can train a model, store that model, and then pull that model back out. So you're kind of doing version control and important parts of the MLOps lifecycle for your machine learning models. So real quick, what is ML monitoring? And we'll go a little bit deeper into some of these as we go. But as you're kind of going through, or data's going through your deployed production pipeline, a lot of different problems can occur. So you might have things like data drift. That's kind of where the data distribution that's coming into your model before it makes a prediction has changed maybe pretty drastically from what your model was trained on. So the distribution shifted quite a bit or drifted. You have data quality issues. Those could happen almost anywhere in your pipeline. That could be at the source before the data is coming in. Could be some sort of pipeline bug that, a schema's changed somewhere, so now the data just doesn't look right before it's making a prediction. You have concept drift, and again, we'll talk a little bit more about this later, but that's kind of where your model is no longer correctly mapping to the right values. And you have things like model performance, where you want to track overall accuracy or bias and fairness of your model. You might want to also look at how or why your model is making those decisions with some sort of explainability algorithm. So ML monitoring is kind of putting all these things together in a way that makes sense for your project and pipeline, and making sure that your models stay performing as intended. And we have a saying, bad data happens to good models. You can do all the evaluation you want once you put a model in production. Chances are things are going to change, and you want to be prepared for that and catch it as quickly as possible. So at WhyLabs, we, again, like I mentioned, make tools that enable data and model health monitoring with a lightweight, privacy-preserving architecture. And we'll talk a little bit more about this as we go, and we're actually going to do a hands-on example with this. But we saw an example here, what a pipeline could look like. With WhyLabs, you have your infrastructure. Then we're going to be collecting some sort of telemetry out of there using WhyLogs, which is an open source library, and I'll talk more about that in a few minutes as well. We're going to collect these summary statistics, like kind of profiles of your data sets, where it doesn't contain any raw data that we can then store in the observability platform, and do things like measure for data drift, concept drift, all those things we talked about that could go wrong. And then from there, we get those visualizations in a nice dashboard. We can set up alerts and notifications. So if an anomaly does occur there, we can either get a message about it or trigger some sort of automated workflow to kick off an annotation job or a retraining of the model, and tie that back into your Databricks environment. So again, I saw more people join, so just want to do a quick setup reminder. Everything is in the description on YouTube as well. But real quick, this can just take 5 minutes to set up a Databricks cluster. So what you want to do, open up that Databricks notebook link. And you can hit import notebook. This will bring up this URL. You can copy that URL. And then in your Databricks account, oops, let me log back in here real quick. 1 second. Did anybody create a Databricks account or WhyLabs account that wants to follow along? All right, so this is the notebook. Once you've got that URL that I was talking about, you can go anywhere in your Databricks account and kind of go into the menu, hit import, and then you can just import by pasting that URL in there, and then you should have a notebook that's open like this. Quickly, we want to create a cluster to run this notebook on, so I'm going to hit create new resource. And this is if you're in the community edition, it can time out after like an hour of being idle or so, and it can take like 5 minutes to spin up. So if you do want to follow along, you can spin this up now, and then by the time we get to it, you should be good to go. You can give this any name you want. I'm just gonna say WhyLogs May 10 workshop. And then we don't need anything crazy today, but you just want to make sure you go into this ML portion. This is going to give us access to ML flow, where we can log the things like models into experiments. And I'm just going to hit the smallest one I can here, just at the bottom, no GPU or anything, create, attach, and run. And then this is just going to take a few minutes to spin up that cluster, and then we should be good to go to run it. So again, links are in the description if you're just joining on YouTube. You can open up that Databricks notebook, create the WhyLabs account, and create a Databricks account if you don't already have one. Okay, so just a little bit more on data quality. I think we already talked about where these can go wrong, but I just want to mention like it could be the direct input sensor, it could be a manual input of data. Has anyone experienced any data quality examples? Again, I'd love to hear it in the chat. Data drift, we already talked about this as well, but just want to give a couple more examples. This is the input data coming into your model typically, and once you put in production, you can experience things like seasonality changes, new groups of users, or maybe consumer preferences have changed if you're making some sort of shopping prediction. A quick example of concept drift, like I was mentioning, this is kind of where the model no longer correctly maps to the correct values that you want to make predictions on. A good example, this is the housing market. If you trained a model in the housing market 10 years ago, maybe the input data is still the same, like if it was just on numbers of rooms or square footage in the house, but now the output prediction wouldn't be correct because the prices were so different 10 years ago. So you'd want to get that new data, get those new prices, retrain your model with those new prices, and then you hopefully aren't going to be experiencing the concept drift anymore. And there's other areas of ML monitoring that we won't be doing hands-on practice today, but we do other workshops on those. If you go to whylabs.ai/events, we have a whole bunch of stuff coming up talking about these things where we go deeper into like model explainability, bias and fairness, and these are also very important. All right, so we saw this kind of graph before. We talked just a tiny bit about WhyLogs and WhyLabs, and we'll go deeper into that as we do our hands-on example. But just kind of want to mention, so we have all these different areas of our model in production. We have this data coming in, we have feature engineering pipelines, and then we have our production pipeline here where we have the feature engineering before it goes into the model that's deployed in production, and then we get the results out of that model. And if you're just getting started with ML monitoring, I would say, worry about the input data directly into the model and worry about the output from that model. And that's a good place to get started if you're doing nothing else. So eventually you might want to put in different points all throughout your pipeline. You might want to check data quality when the data first comes in, that it's as expected. Same with after feature engineering. And then you definitely want to do it before it's going into the model, and then as it comes out of the model. Just the inputs and outputs of the model can tell you a lot. And that's where we're going to mainly be looking at today. But I just want to mention that you can put it all throughout your pipelines in Databricks, outside of Databricks, but it would look something like this in Databricks. And just want to mention that you might be using Databricks for part of your ML pipeline, but maybe it's not 100% in there. WhyLogs can also collect telemetry from basically any Java or Python environment, and then you can log those all to one place, whether that's WhyLabs or somewhere else that you're storing those profiles. So it's a good way of tying a whole bunch of different services together as well, and gaining visibility throughout your pipeline, no matter where it lives. Just a little bit more about WhyLogs. So about our privacy preserving telemetry. WhyLogs can do data logging and data validation, and then we can use those logs for ML monitoring. And again, we'll see that in a couple different ways today. Just in a few minutes when we do the hands-on part, we'll see how we can store these logs in WhyLabs, but also how we can just use WhyLogs inside of a Databricks notebook and do some stuff there. It's incredibly fast. It works in distributed environments. We have a really good blog that talks more about this, and we have a lot of integration. So we can integrate with a ton of existing libraries, and even if you don't see an official integration listed, there's a pretty high chance that we can work with it. You can run WhyLogs in almost any Python environment, and if you can get the data in a dictionary or a pandas data frame or an image or an embedding, we can log that and monitor it, which is pretty cool. And just a tiny bit about WhyLabs. It's the only data and monitoring solution on the market right now that can be used as a SaaS by almost any industry. And again, the reason is because the WhyLog profiles don't really contain any of the raw data. They're just summary statistics. And you'll see what this looks like in a second when we go to the hands-on part. But some companies will be pretty adamant about wanting an on-prem solution because they can't send raw data out. But it turns out that, they can be okay with a summary statistic of their data. And of course, we're AWS. We have great security standards, and we're SOC 2 compliant. All right, so enough slides. Is everyone ready to see some hands-on stuff? Again, if anyone in the chat has any questions too, you can post them there. But we're going to get to the hands-on part. Again, the links are in the description, or if you look in the chat, they should be there. The main thing is you'll want to open up that Databricks notebook, like I had mentioned, and create the WhyLabs free account. So I have my Databricks notebook, and I spun up the cluster, and I should be ready to run this. Is anyone stuck yet? Does anyone have any questions before I start running the code in the Databricks notebook? All right, I'm going to go ahead and run it, and feel free to ask questions as we go. So here, my cluster is live, and I can now run this hosted Jupyter notebook on Databricks. And I'm going to first start with pip installing WhyLogs. Most of the other libraries that we're going to use are already installed in here. The only one we need to install is WhyLogs. We're going to install it with the MLflow and WhyLabs and visualization dependencies, all stuff we're going to use today. This should take under a minute. I think it'll tell us exactly how long it takes in a second. Should be almost done. And done, 30 seconds. All right, so now we've installed our requirements here. Let's go ahead and import our libraries that we're gonna use. We're gonna use WhyLogs, NumPy, Pandas, Datetime, and OS. And then we're gonna import train test split from scikit-learn. And we're gonna load the iris dataset. The point of this is we're just gonna train a baseline model that we can start making predictions on, and logging that model with MLflow to the model registry that we can pull back out. So let's create a quick function to get data. Here it's just going to load the iris dataset. It's going to turn it into a pandas data frame, and we're going to return that data frame together with the features and target values. Let's run it, and then we have this df iris variable that is our iris data set for training. And we can see it looks like this. We have our 4 features, the sepal and petal length and width, and then the target value. Now let's go ahead and create our training model function. So we're just going to pass in that data frame. Again, I won't go too deep into this, but we're going to just quickly train a k-nearest neighbor model. We're going to get the x and y values, the features and target values, and then we're going to split those into a train test split here. We're going to use 30% of the data for testing just to see how accurate our model is on the test data. And it will just fit it here, and then we'll get the k-n score by passing in the x test and y test. And then here, we're going to use MLflow. So MLflow is a cool way of storing models and data kind of as a in a registry. You'll see what this looks like in a second. So we're going to import MLflow. We're going to start an MLflow run. And then we're going to use something called autolog. It's going to auto kind of figure out which binary to save the scikit-learn model in this case. And then we're going to get our data. We're going to train that model. And then you'll see we'll get this variable run ID, and then we're going to close out that MLflow session. And we can see that if you're running this in Databricks, it says 1 log to experiment. And if you command or control click this open in a new tab, we'll get this Databricks experiment tab, and we can see all the different runs I've done here. I also love seeing the random names it gives them, which I always think is kind of fun. But let's look at this one we just ran 40 seconds ago. So this is our MLflow registry in Databricks now, and we have this model folder, which we can see has our model.pickle, some other stuff contained around our model, as well as our confusion matrix on the training data. And if we click back on this model folder, it gives us a useful little snippet of code here to kind of pull our models back into the notebook if we want. So we can see this is our run ID, or this is my run ID. Yours will be a little bit different. And you could just essentially copy this if you wanted to quickly pull your models back in production or back into your notebook. So this is a great way of versioning your model and data. So we could update our data set, train a new model, and then have it logged back here and keep track of the models all in one place, and then figure out, if we trained a new model and it was better and we want to put that one in production, we can do that. If we put in production, ends up it wasn't that good, or wasn't better, we can actually go back and just pull a different model out of our registry here. Let's go back to the notebook. And I do have a section here just commented out. So if you run this in a local Jupyter environment or in a Colab environment or something like this, you won't get the nice Databricks registry, but it will create a local folder. So you can uncomment that if you want to run it there. And if you do happen to be running on that Colab notebook I shared earlier, it has it uncommented, and you'll be able to run it just fine. So let's go look at what a profile looks like for WhyLabs if we haven't seen this yet. We're just going to profile that same data frame that was all the training data set. And then we're going to look at the result and look at it in pandas. And it looks like this. So remember I mentioned that WhyLabs contains summary statistics of your data. So in this case, it was a tabular data set. We saw it had the feature values, petal and sepal width. Here, we can see that it has an estimated cardinality. So out of that 150 rows, which we can see here for petal length specifically, there is 43 unique values. Petal width, there is 22, etc. And we can see there's 3 different targets in that class as well. And then we get these other statistics like the mean, the max, the min, and quantile distributions, and some other stuff like, was it a string, or how many strings were there in that data set, or integers or floats. And we can see that they're all actually fractional. So we had 150 rows. There's 150 fractions in that case, except for our target column, which makes sense because that was all 0, 1, or 2 based on the class that it was trying to predict. So it turns out with all just this summary statistics, you can actually do a lot for catching things like data quality and data drift, which is what we're going to see with these profiles in a second. But first, I want to show how you can also write this profile to your MLflow model registry. So if you want to save a profile of each training data set, again, when it's in production, it's probably going to be something that you're going to be updating fairly often. You're going to probably train your model to improve it, and then you might want to log this profile of that training data set to use as comparison for data drift. And we're going to see that in action in a minute. We're going to look at this training data summary and then look at new data and see how it compares to it. And then that tells us a lot about like if the data is drifting or not. So here, I'm just making another function that we're going to add into our ML flow. We're just profiling the data like we were before, passing in the data frame. And then we're just doing one specific thing is we're calling .writer ML flow. So that's when we imported the ML flow dependency, it gave us that feature where we can now log this to ML flow. So run this. This is very similar before. We're getting our data. We're training our model on that data. And then we're here logging the WhyLabs profile now. And then again, we got a run ID, and then it just ends that session. So if I go back to my experiment tab, and now we see we have this one from 17 seconds ago. I can go in, and just like before, we have our model and stuff. But now we have a WhyLabs folder as well with our profile in it. So now we can always bring in the profile of the training data that was used to train the model, and always have it tied to that specific model. So this is important. Again, if you're in production, you want to retrain your model, you can kind of pull these out. And again, if you're running this not in the Databricks environment, you can uncomment this code and pull it out this way. So let's quickly look at our artifacts here. We're going to pull them back in the notebook. This is just using the MLflow client to kind of pull these folders down. You can see we're calling WhyLabs and model, the things we looked at in that experiment folder. And we can see now that we have the WhyLabs profile in here, and we also have all those things that were in the model folder, the model pickle, the requirements, the conda, everything we would need to set up our model for production. And here we pulled our WhyLabs profile back out. So you can register that training profile and then pull it back into your notebook and then view it again. And so this is where it comes into where we can store these things in Databricks and MLflow and then pull them out and use that training profile for comparison for data drift. Any questions so far? I see someone said hello. Someone also said elbow cuff. I'm not sure what that means. All right, so we're gonna get to a little bit more exciting part here is we're gonna kind of simulate that our model is in production. So again, if you haven't signed up yet, you'll need this in a little bit if you're following along. Share that one more time in the chat. Pretty soon we're going to log all this data to the observability store, where we can kind of visualize and set up monitors on our data in production. So this cell looks a little crazy. All I'm doing though is importing 7 CSV files, and then I'm just really putting them into a list here called DFs and DF targets. So I'm separating the target values from the CSVs here, so we can kind of simulate that we're running these this data, or simulate we're getting this data in production, making predictions on it without the target, and then I'm going to add those targets back in for ground truth though. And so now our data frames in that list should look something like this. So we have our sepal length, our petal length, etc. These are all the features that our model's trained on to make predictions. And again, this is what a profile looks like and how we create a profile in just a few lines of code. So this gives us those neat summary statistics that we can do a lot of stuff like I've mentioned, check data quality, and monitor for data drift. And we'll see that in action now. So first, we're going to show what it looks like to write these profiles to WhyLabs, and then we'll go in a little bit later after that and look at some of the stuff you can do directly in the notebook here with WhyLabs, the complete open source product. So if you haven't already, sign up for that WhyLabs account, and your homepage should look something like this. You won't have these same projects. You might have less projects. I want to go ahead and delete one of these actually. So I'm going to go to settings. If you have too many toy projects that came with it, you can also delete them as well. So no matter where you are in here, you can go to settings, go to model and dataset management. I'm going to edit these, and I'm going to delete this one. And from here, I'm going to create a new model. So I'm going to call this WhyLabs, Databricks. You give this any name you want. I'm going to go ahead and say classification model. And we're going to hit add models or data sets. And we should be ready to go. And if you want to come edit this ever, you can. Just hit the edit button that will appear over here. And you can select, like if you forgot to put in classification model, or you actually are doing a regression model, or you're doing some sort of other data stream in here, you can set this here and you'll get some other features when you're monitoring for performance. So here, we're going to be good to go. And you just want to get your model ID from this page. So my model ID is 168. Yours might be 0 or 1 or 2. We'll go back to the Databricks notebook. I'm going to put in the model ID. And then I want to get my API key next. Again, from the WhyLabs platform, same page. There's just a tab up top here that you'll want to click on to get access tokens. I'm going to create a new token here. You can name it anything you want. I'm going to hit create access token. I will get this URL, or sorry, this key. Go back to my notebook, paste in this key. One more thing from the same page is just the org ID. So it shows up here. It also shows up here. So I'm going to go ahead and copy it. And I can now run this. And I got no errors. I should be good to go. And now we should be able to write those profiles up to WhyLabs and use some really powerful features there. So go ahead and import this WhyLabs writer. Let's write a single profile. You can see this is just a couple lines of code here, a few lines of code. We're going to initialize the WhyLabs writer. We're going to profile our data like we've seen before, where we're just passing in that CSV file or data frame in this case, and we're getting those summary statistics. And then we're going to write those profiles to WhyLabs. So now if I go back home, you can just hit that WhyLabs button up top. And I want to go view my data. I can click in. You'll see that we already have 4 features coming in. These cards get more interesting as we pass more data, which we'll do in a second. But go ahead and you can go to this profile tab, and you'll be able to see that we should have one profile. Maybe if I reload it. We'll come back here in a second. If we go to the inputs tab, we can see that we have a profile in here, and something, maybe it's taking a second to log up. Or did I do something? Oh, okay. So I accidentally had this date wrong when I clicked into it, and this can happen sometimes. Or it's a really useful feature to select which dates you want to view. Occasionally, though, like you might be selected on a date that your profile is not in there, and you won't see it, just like I did. You can always hit this little profile lineage button here that'll always bring you to the dates that your profiles are written to. So by default, our profiles is written to the date and time that you send it, like we did here. So we just are writing it up by default. It's the date and time that we wrote it, but we can override it. And we're going to do that in a second down below. We can see here we have our single profile. It's not super interesting maybe to look at quite yet, but we can see all those statistics that we saw before in the profile. So we have like the min, the max, the mean, etc. in here. And then let's go back to the notebook. If you run the next cell, what this is going to do is it's going to loop through all those data frames that we had created with those CSVs, and then it's going to subtract a day for each one. So it's going to write it and kind of simulate as if we had data we collected for 7 days. So this ran. I'm going to go ahead and zoom out, and I'll refresh the page. And again, we can now see the profile lineage change from just being May 10th to May 4th to May 10th. So I'm going to click that button. That's going to bring us to this view where we're looking at those 7 days. So now we have 7 days of data in here that we can start kind of inspecting visually right away. You can scroll down. You'll see some other statistics here. Like I actually really like looking at the estimated mean that we see here. That's really helpful for a lot of data. And we also see this up here. So again, if I zoom in, you can see that we have the median, the max, the min, and some more values here. It depends on what your data is, what you might want to be looking at. In this case, we'll just look at kind of the min, the max, and the median. That's going to give us a good kind of a pulse on how our data is changing. So we can see the median's 4.2, it's 4.3, and these for each day is 4.2 again. Then all of a sudden on this other day, it goes all the way up to 9.2. So quite a drastic change probably, right? Maybe something went wrong with our data collection, or maybe we got brand new users in our data set and they're behaving completely different than the other distributions on these other days. And then this one we can visually see kind of is ballooning out in both directions. We can see the median didn't change that much. It's 5, but the max definitely is way higher than any of the other days. And same, I think the min is 0 as well, which the other days the min was 1. So something could be wrong with some of the profiles on that day ingested. This next one's all zeros. That's pretty interesting. I would expect if I was getting measurements for something, they're probably not going to be 0. And again, that could be a data quality issue where we might want to set up some sort of validation in our Databricks notebook to check, like, don't run a prediction if it's under 0 or throw an error earlier. And then this last profile looks kind of normal again, or at least normal from the first 3 days where the median's 4.2. So this is great. Visually, we can kind of start seeing that maybe something's going on with their data, but we probably don't always want to come in and visually check what's going on. So I'm going to go back to our notebook, and if we run this one more cell below the last one we ran, this is writing a reference profile, and this is actually using that profile that we pulled out of MLflow. So we know that this training data was profiled and stored in MLflow. We're going to pull that back out in our Databricks notebook, and then we're going to write it as a reference profile, which is a static profile where we can now take this data that we're looking at here, compare it against that training data, and see how much the distribution has shifted. So we can go to Setup Monitors from here, and let's go ahead and select this data drift for model inputs section. We're going to hit Configure. We can see our options here. One thing I want to do here is we're going to make this a little bit more sensitive. So we're using something called Hellinger distance to calculate the drift. There's different types of algorithms you can use to calculate drift. That's just different ways of looking at our data to see how much the distribution has changed. We're going to make this a little bit more sensitive. So anything over a 0.6 change of distribution, we're going to trigger an alert for. And then we're going to go to this next tab. And by default here, it's selected as a trailing window. So it's basically looking at the last 7 days and looking for anomalies in that data. You can select this to look at like 60 days, 90 days, etc. See if any changes in your data has happened in that amount of time. Or we can select a reference profile. So this is our training data, and we're going to be comparing any new data profiles to see if the distribution has changed according from our training data set. And you have an option of setting up, like, do you want an email or Slack notification? Do you want to trigger something with PagerDuty? PagerDuty is really cool. So if you want to detect when data drift happens and then do something like trigger a automated annotation job or trigger some sort of other Databricks workflow. So if like data drift happens, you want to get new data, retrain your model on that data, you can kind of have it all automated from here, which is really neat. So we set up that monitor, and again, we'll go to the inputs tab, we'll go look at pedal length again, and now we can hit preview on our monitor, and let's see what happens. And chat has been a little extra quiet today. I still see quite a few people watching, but no one's asked any questions yet. And from here, so now we were comparing any of these profiles for each day to that training profile that we pulled from MLflow. And we can see we have 3 alerts kind of notified in our preview here, where all the ones we kind of pointed out that looked very different all got triggered with drift. And if you zoom in, again, you can see the drift distance shown here. So this one where the median went up quite a bit, that's a huge amount of drift. The higher the number here, the more the distribution change from our training data set. This one is also, pretty big, over 6. And this one's huge. That's all zeros. So any questions so far? I know we've gone kind of fast, and no one has said they've got stuck, which usually someone has. Or is everyone just watching? So now we've set up a system in our Databricks notebook where, we can look at all the input data coming into a model, log that, compare it to our version of the training data set the model was trained on, and then monitor for any distribution change or data quality changes in that monitor manager. In the presets, you'll see there's a whole bunch of different ones you could choose from for data quality, for model performance, ingestion health, and then you can also create a new custom one. These just kind of give you a little setup to make it easy to get started. And then you can also go in and really get into customizing this with JSON. You can read the docs on more how to do this. All right, so if we go back to the notebook real quick, we've logged our training data set. Now let's go ahead and log some predictions. So in actual production, it depends on how you want to do this. There's so many different ways that you could log predictions and log data. You might do this all in one place. So I kind of broke it out in the workshop to make it a little bit easier to follow along potentially. But now I'm going to go ahead and make predictions with all those data frames and then log them up for the same days. But in production, you might use something like this where you're aggregating them all into one data frame or one Python object. So here, like you could be getting that data, getting the class output, getting the class probability output, and then just logging that in one sort of data dictionary and logging that up in one call instead of doing it in two that we're doing right now for the workshop. So here in this code cell, I'm going to create something called logged model. And if you remember before, all the way up when we ran our ML flow, we got this model path. So now we had pulled out that model that we stored in ML flow directly in our notebook, and we can start using that model. And again, it's cool using ML flow as your model and WhyLabs profile registry, because this way we know these are the same profiles from the trained model and from the training data set that model was trained on. So again, those things might be changing in production, and ML flow is a great way of kind of keeping track of those, and then you can pull them out just like we did here, and then make predictions and monitor based on those values. So here we're loading in the ML flow model and then just making a prediction on one of the data frames just to make sure it's working, which it did here. And then here we're going to just loop through all those data frames again, and we're going to tack on the model predictions. So now we have our class output here, as well as the feature values. So then we're going to write it to WhyLabs, similar to like we did before. We're just going to loop through each of those data frames, except for this time, we're just going to be passing up that class output. So we're just going to be passing up the class now because we had already logged all the feature values before. And like I was saying, you could do this in a couple different ways, whether you log it all at once or break it out in this way. It doesn't really matter as long as they get kind of profiled in the same day in this case. So if we go back to WhyLabs, let's look at this output tab. Might take a second to write up there. Refreshed it. We have our class output. And now we can see kind of the distribution of what our models are making predictions on for each day. This is again, if we don't have ground truth, like I'd mentioned in the slides, you want to start by looking at the model inputs and model outputs. So even just by looking at the model inputs, we saw that there's a distribution of drift happening in data. So we think our models might not be performing as well on that data potentially. And we can look at these kind of predictions throughout the days. The first 3 days look normal. The other one, that was the one that went really high. And we can see that, its predictions were mostly Virginica. And then the other one that wasn't like crazy, like distribution shift, but it definitely shifted quite a bit. And we can see that the distribution of predictions did shift. So like if we were expecting most days, we always get an even distribution of predictions. And then these 3 days that we saw the data drifted on are giving us different prediction results. We think something might be up here. And so we can drill back down into our data set and see, what is going on. And like we saw, this one was all zeros. And with k nearest neighbors, if you don't have any data validation happening, it's still just going to be looking at the nearest neighbors to whatever value it got and making a prediction on it. So even if it was all zeros, it's like Setosa has features closer to 0, and it's just always making predictions that it's a Setosa class. And then this one looks normal. So we can go back in to our notebook, and we'll just log a couple more things. What we're going to do here is just tack on to those the ground truth values that we had before. So now our data frame looks like this. So we have the feature values, the class output, but then we also have the ground truth. So now we can measure actual performance metrics like accuracy, F1 score, etc. And I'm going to log those up to WhyLabs, very similar to like we were doing before, except for I'm using this y.log classification metric instead of just the whole profile. And then we're just selecting the columns that we want to do classification metrics on. So that's something like the ground truth and class output. So we go to this performance tab. Now we'll see again, if we actually had annotators go in and get that ground truth for us, we can see that our performance did actually drop. So we know 100% sure that data for those 3 days definitely was affecting our model. But it's cool how much we could figure out that it was affecting our model without even having the ground truth. So just looking at the inputs alone gave us a lot of data to think that our models might not be performing right. And that's where I mentioned you might have some sort of automated job setup where you're just looking at data drift. That triggers some sort of workflow where you have someone annotate data, kick off something in Databricks where you can annotate data, retrain a model on that new data, and then you could actually deploy it and then look at how that new model is performing on the same data sets. And then you could do actually, might overlay the same. You can do model comparison in here. They had the same data, so I think they're just overlaid exactly the same here. But if you had a difference in model performance, you could then track that here and say, well, if the model is better than the other model, deploy this better model that was just shadow deployed before. And then there's other features we didn't talk about in here. So like I talked just quickly about bias and fairness. One way of doing that is segmenting your data so you can, make sure that your data is performing fairly or unbiased on specific segments or populations of your data. And I'll talk more about that in a different workshop. Again, I'll share the link actually. There's upcoming workshops. And one of them we're going to go deeper into kind of all those features. But back to our Databricks notebook. Again, any questions so far from anybody? We kind of saw so far, we're using a Databricks environment. The notebooks in Databricks are awesome. You can do a lot of stuff with them, schedule them to run on certain, jobs or times. We saw how to log data with MLflow. We saw how to pull out data from MLflow, our experiment registry. And then we saw how to log that data to WhyLabs and compare it for things like data drift, etc., in the WhyLabs platform. Next up, we'll go quickly and talk a little bit about using WhyLogs, the open source library, directly in the Databricks notebook environment. So I'm going to go ahead and run this code cell. This is just going to create profiles of all of our different data sets just so we did it in one place. And now we can start using these profile views and comparing them against each other. But you could pull in that MLflow profile that we had pulled in previously if you want as well. So here I'm going to call the notebook profile visualizer from WhyLogs, and we're going to pass it two profiles. So these are two profiles you want to compare. Again, maybe you'd want to pull in that profile that we stored in Databricks and then compare it against another profile. Then we'll run this drift report. And what this is going to give you is a little visualization here. Oops, sorry, I jumped up. You'll get a little visualization giving you an idea of what the data distributions might look like for those two profiles. And then the most important thing probably to look at here is this drift score. So the higher the number in this case, the less drift there is. And you can change which algorithm you want to use to detect data drift. And I'll talk more about that in a second. But here we see, there's a total count of 150 rows. There's no evidence of data drift. And this is the drift score that we get. If I scroll down, maybe we want to drill a little bit deeper into each set of features and overlay that data in a histogram to see what did the distribution look like visually. We can see that here, obviously there's a little bit of shift, but not that much. Most of the data is overlaid in the same points, so we have a pretty low drift value here. Let's look at one more, the petal length. This one is even less of a drift. They're basically all overlaid in the same spots. And we can get all these raw values with WhyLabs. So if you want to use, write something to actually get each of these score values and make a decision based on it in the Databricks notebook, you can do that here as well. We'll do one on one more profile where we're going to compare profile 1 and profile 6. Here we can see the values is super high. So let's look at, I think I might have said this backwards about oh no, I did it right. Okay, so most of these don't have drift, right? So like these are a value of 1 and it says no drift detected. That's because they're almost probably perfectly overlaid in their distribution. Except for we have this one, the petal length, where it says drift is detected, and this is a really tiny number. So let's look at what's going on there. So that is the petal length is the one with a lot of drift. So we visualize what that looks like. We can see there's only a little bit of overlapping of data distribution, but most of them are completely different. So a lot of this reference profile is way higher, and this other one is way lower than the reference profile. But if we looked at petal width, the one where it said no data drift detected, you can see that this is actually almost perfectly overlaid. The only part where it isn't is right there. So that's why it was like a score of 1. And again, we can get those raw values by using the calculate drift score function from WhyLabs. And then again, I'll go really quick. We're almost over at our hour here. We can use something called constraints in WhyLabs, where we can compare, or we can write kind of unit tests for a data basically, and see if the data in our profiles match those rules. So we saw what those profiles look like, where we get some statistics like the min, the max, the mean, etc. Also different types of data. So is it a string? Is it a fraction? Is it an integer? We might kind of probably know what our data should look like. So for example, we had a profile that was all zeros. And again, if we were measuring something in this case, I would think we should never have a 0. So we might want to write a unit test saying, if the data is 0 or below, something's wrong there. Maybe we shouldn't run a prediction on our model. So we use something called constraints in WhyLabs. We'll import some functions here to build it. And then we're going to create a function called validate features. And we're going to initialize the constraint builder. And we're going to just kind of write these rules here. So we have our name. This is text. I like to write out what the rule is. So saying petal length is above 0 and below 15. And then we have our metric name. So we're looking at a distribution that was in the profile. We'll see this again in a second, but it'll say distribution, and then it'll say min, max, etc. So it's a distribution feature, and then we're going to look at the column name of petal length, and then we're going to say on that distribution feature that the min is over 0 and the max is under 15. So we're going to do that kind of for all those 4 columns here. We can go ahead and run this. And we'll pass in profile 3, and that's going to give us this kind of little result here where it says the string that we named it, and then it says 1 and 0 in this case. So 1 means it's passed in this column. If it was a 0 and it was a 1 here, that would mean it fails. But let's look at what it looks like in this kind of visualizer, where we can see that all of these pass. And so this is really neat, especially if you have a ton of these. So in this case, we only have 4. We could kind of decipher this. But maybe you have like 50 or 100 different tests on your data. You can quickly visualize it here. And you can even do things like filter. So if you want to just look at the failed ones, the passed ones, or search, etc., you can do that there. And if you want to use this in some sort of Python function just to quickly test, did they all pass or fail, you can use this validate function on it, and that's just going to return true or false. So if they all passed, it's going to say true. If any of them fail, even just one, it's going to return false. So a quick way to check, did my unit test pass or fail? And if we looked at this one, that was the profile 3. We can see that they all pass in this case. Let's look at one more. Profile 4, they all failed. And if we looked at that profile, it is because this is the one where it's all zeros. So our unit test said we wanted to make sure it was above 0. In this case, none of them were, so all those columns failed. And that's a quick walkthrough of using WhyLogs kind of with MLflow inside of a Databricks environment. And then we also saw how to write those to WhyLabs to set up monitors on our data. There's a lot more resources here, so if you want to learn more about WhyLogs in general, you can go to the GitHub. That's a good resource. There's a ton of examples in here as well. I'll bring that up in a second. Again, a lot of different integrations can be used in most Python environments. And then one quick announcement too before we wrap up actually is we're looking to test some new features with WhyLogs and WhyLabs. And if you're interested in participating in a usability study next week, we'd love to invite you to sign up and do this quick survey. And then see if you want to test out new features for us. That would be really helpful. And of course, if you're following along or copied any of the notebooks, all these resources are resource links you can click on. Any questions? Chat was super quiet today. Someone said, thank you for your time. No problem. Hopefully you found it useful. Was anything interesting? Is there any other Databricks features you'd like to see maybe in a workshop or some other content tied in with WhyLogs specifically? Like if you're using some sort of feature, is there anything you'd like to see how it could tie over with WhyLogs or WhyLabs? Did the WhyLabs or WhyLogs monitoring piece seem interesting to anybody? Someone else said, thank you. Thank you for coming. And yeah, again, if you have any questions, again, maybe this was almost one of the quietest chats, even though I see people here. If you have any questions later, feel free to join the Slack channel. Like I mentioned, I'm in there. A lot of other people or our whole team is in there. So if you have any questions about using like WhyLogs or WhyLabs in a Databricks environment or any other environment, let us know there. There's also an introduction channel. So if you just want to say, hey, that's a good place to stop by and tell us a little bit more about what you're working on, or tell others a little bit about what you're working on. But with that, if there are no other questions, I'm going to go ahead and wrap up the stream. I'll wait one more minute to see if there's any questions. Did anybody follow along in the Databricks notebook? Always looking to see too if I can make it easier for people to follow along. Awesome. Well, I am going to go ahead and end the stream. Thank you so much for everyone who came out. Someone said, nice presentation. It was clear, hence no questions. I can't have been that clear, everyone. But hopefully you found it fun, and hopefully it was clear enough, I guess, where you didn't have to ask any questions. I take that as such a big compliment, but I don't know if I believe it. But if you have any questions, like I said, later, maybe you're going to be using a different environment, different type of model or something like that, please connect with us or me on Slack. And I'd love to hear, again, if you go through and maybe implement this in your project, that'd be awesome to hear about as well. Thank you so much, everyone. I will go ahead and end the stream for real this time and hopefully talk to some of you later.